Hello everyone, myself Angad Johan, a PhD scholar from Ravindranath Tagore University. Today I am going to present a topic on nuclear chemistry. So let's start. So our first topic is nuclear chemistry. What is nuclear chemistry? Basically, nuclear chemistry is a branch of chemistry which deal with the activities of nuclear structure, nuclear reaction, and nuclear atoms. Okay. So next topic is radioactivity. So what is radioactivity? Radioactivity is the act of emitting radiation continuously. Okay, suppose there is an element which is emitting some sort of energy, okay, in the energy and trying to make itself stable. Okay, so this amount of energy which is been radiated is called radiation, and this phenomenon is called radioactivity. Okay, and the element which produce this radiation are called radioactive element, such as polonium, uranium, thorium. Okay, and what is the reason behind this? The main reason is to get the stability. See, so all the atoms are generally not stable in their original state. Suppose this element which I have told, see these atoms, they do they do generally do not exist in a stable state. So they, in order to get the nearest stable electronic configuration, they do release some sort of energy. Okay, and this sort of energy is called this radiation. So the main reason behind this radiation is to get stability. Okay, everybody tries to get stable electronic configuration. Our next topic is representation of an atom. Generally, atom is represented in the AXZ format, where A stands for mass number, X is, stands for symbol of an atom, okay, and this Z stands for atomic number. And we all know our mass number is constituents of proton plus neutrons, and our atomic number is made up of proton, and which is equal to number of electrons. Okay. Our next topic is radiation. As I have told earlier, what is radiation? Radiation is the emission of energy in the form of particles or waves through space. Okay, suppose there is a radioactive element, how it will release its energy? It will release its energy in the form of particles or waves, electromagnetic waves. See here, there are three types of radiation. Okay, alpha rays or alpha radiation, beta rays or beta radiation, gamma rays or gamma radiation. In this ray, alpha rays and beta rays are emitted in the form of particles, and this what is this? Yes, this gamma rays is released in the form of waves. Okay, so let's see first what is alpha rays. So whenever the radiation is released in the form of alpha radiation, okay, means the radiation which has two neutrons and two protons, okay, are called alpha rays, and they have certain amount they have certain properties. Suppose they have a charge of +2, see, two protons, charge of +2, and the combined mass of 4 unit. Okay, and as compared to beta and gamma particles, alpha particles are a bit heavy and they move a bit slower, and they have very less penetrating power. Suppose if you put a piece of paper or piece of sheet in front of this alpha rays, then it can be blocked. Alpha ray cannot pass through this. Okay, so next comes the beta radiation. So beta radiation is a bit heavier than alpha radiation, but a bit weaker as compared to gamma radiation. So it is in between this alpha and gamma. See here I have written beta particle have medium penetrating power, as they can be stopped by a sheet of plastic or aluminum. Okay, so beta particles have a charge of -1 and mass of 1/1200 of the proton. This means that beta particle are same as electron, so we can say beta particle as electron also. Okay, as I have told earlier, beta particle can move a bit more faster than alpha particle but slower than gamma particles or gamma rays. So let's see, third types of radiation is gamma rays. So actually gamma rays are not particle. As I have told earlier, they are waves. Okay, so they don't have any mass or charge. And gamma ray have high penetrating power, so it can pass the sheet of paper as well as the sheet of aluminum or plastic. So we need concrete or heavy boundary to contain this gamma radiation. Okay, so let's move the detection and measurement. So in order to detect the what type of radiation, there are different mechanism has been developed over the period of time. Such some of them are cloud chamber method, ionization chamber method, Muller counter, okay, film gauges. So I have used one to make you understand. This is the cloud chamber method. In cloud chamber method, this is the setup. See, there is a camera, and there should be one window, and there is the source of radioactive substance, means from there the radiation will come out. Okay, and this chamber is, the whole chamber is dust free, and water vapor is there. Okay, and this is a piston. The basically role of piston is to push the ions or atoms, to push the ions or radiation in this chamber. Okay, whenever the radioactive substance is allowed to pass through the chamber, and from here we can see. Okay, so whenever we allow this mechanism to start, then we have to increase the pressure in this chamber. How can we increase? We shall apply this piston by pushing it upward. Okay, as the piston is applied, then what will happen? There will be less space to for the radiation moving in the chamber. Okay, as the radiation contains alpha, beta and gamma particles, so in the water vapor, what will happen? They will try to combine with this alpha, beta. The alpha, beta and gamma particle will try to combine with the water vapor. Okay, and as they will combine with water vapor, we can see the we can detect the alpha, beta and gamma radiation. Suppose whenever the alpha particle will combine with the gas vapor, we shall see one narrow line. Okay, and when beta particle will combine with this gas vapor, we shall see a bit thicker line. And if we do not see any kind of line, then we can say that then this no line detects or the no line tells that this is a gamma radiation. Okay, generally we know if there is alpha particle, if there is radioactive element, it will emit three types of radiation: alpha, beta and gamma. So alpha particle can be, or alpha radiation can be detected by thinner line present in the chamber of high pressure, and beta particles can be detected by the wider line, and if there is no line, then we can say that it is a gamma particles. Okay, so let's see our now radioactive decay. What is the radioactive decay? What happens whenever there is certain types of atoms which are radioactive? They at certain point of time, or at one point of time, they will get their stability by losing energy. Okay, so this phenomenon of losing energy is called radioactive decay. Suppose, see here, the process by which an unstable atomic nucleus loses energy by radiation is called radioactive decay. Okay, and the original atom is called parent nucleus, and the product which it will release and become stable are called daughter nucleus. Okay, okay, so radioactive decay are of two types: alpha decay and beta decay. Okay, and why it is not and why not gamma decay? Because gamma is does not contain any particles. Okay, so we cannot we cannot find the gamma decay. Okay, so let's see alpha decay. See here, this is a parent nucleus which it will come here, and it will try to be stable. Okay, it is called daughter nuclei, and the amount of energy and the particle which it will release is called alpha particle. Okay, see here, this is thorium 9231 is an stable nucleus as compared to this, and this is our alpha particle. So our so our alpha particle has mass of 4 unit. See, our alpha particle has mass of 4 unit, and the mass of 4 unit and atomic mass of just a minute, it has it mass of 4 unit and 2 unit of positive charge. Its charge is 2 or atomic number is 2. Okay, so these are the some of the properties of alpha radiation. Next is beta decay. Okay, whenever the nucleus or whenever the element loses its electron or tries to come or get the stable electronic configuration, they release energy, and whenever they release energy in the form of beta radiation, this is called beta decay. Okay, similarly previous one was alpha decay. Whenever they release energy in form of alpha particle, then this is called alpha decay. Okay, there are some of the properties. This see this is the property. This is our parent nucleus, which when it will release one electron, so this is called our beta decay. Okay, our one electron is released or some element is released whose charge is -1, and this is our parent daughter nuclei. Okay, okay, so from here we can say that in beta decay the atomic mass of atomic mass will be m, and the atomic number will be z plus 1. This is the mass of beta, okay, beta particle. If the mass of beta particle m, and atomic number will be z plus 1. Okay, now the unit of radioactivity is represented in 3 different types of unit. Okay, first one unit is standard unit. So standard unit is represented by Curie unit. Okay, Madame Curie gave this unit, so it is called Curie unit. And 1 Curie unit equal to 3.7 into 10 to the power 10 dps, and dps here, dps stands for disintegration per second. Okay, and our SI unit is becquerel. 1 BQ is equal to 1 dps, means 1 becquerel equal to 1 disintegration per second. Okay, so our third is means third unit is very frequent. Okay, means very recent unit. Nowadays this is used very frequently. So the third unit is Rutherford. 1 Rutherford is equal to 10 to the power 6 dps, means disintegration per second. Okay, so next is application of radioactivity. So as we know, radioactivity has many applications. Okay, suppose its isotope is used in different types of atomic reactor. Okay, we know atomic reactor, which provides the cleanest source of nuclear energy. Okay, or cleaner source of energy. Okay, it has been used in medical instruments and food in common application. Okay, it is used in industries, medical instruments. Okay, and alpha particle has been the alpha particle emitted from radioisotope as used in nuclear reactions. Okay, and in agriculture, calcium phosphate containing radioactive phosphorus is also used in trace amount of phosphorus by the plants. Okay, so cobalt 60 is extensively used in the treatment of cancer. So these were the some of the examples of radioactivity. Okay, thank you.